Hello everyone, this is Professor He. Nice to see you again. The topic of this task is about the real gas and the ideal gas. Almost all the working fluids in the engines are gases. For convenience, the gases are artificially divided into two categories in thermodynamics. One, ideal gas, which is a hypothetical substance. Two, real gas, which is a real substance. The ideal gas model is based on two assumptions. The first one is that the gas molecules are elastic particles that do not occupy volume. And the second one is there are no interaction forces between gas molecules. For the real gas, the molecule has volume and forces between the molecules, while for the real gas, the molecules has no volume and no force between molecules. The difference between real gas and ideal gas is not too much. One, when the specific volume of the real gas tends to infinity, it becomes the real gas. Two, the forces between the molecules gradually disappear with the infinite increase of the distance, and in this case, the volume of the molecules is very small compared to the volume occupied by the gas. A real gas that does not satisfy the two assumptions for the ideal gas and does not meet the equation of state of the ideal gas is called real gas. In engineering, when the pressure of the gas is relatively high and the temperature is low, there will be a large error if it is treated as an ideal gas, and it should be treated as a real gas. That is, the volume of the molecule itself and the forces between the molecules must be considered. Examples for real gas: working fluid in high-pressure equipment, low-temperature working fluid, working fluids in steam turbines and refrigeration equipment. There are some tips for the gas model selection. Gas state, not specific volume, is regarded as ideal gas. Otherwise, it is regarded as actual gas. Calculation accuracy. Low accuracy requirements can be regarded as ideal gas. Otherwise, it is regarded as actual gas. Gaseous working fluids commonly used in engineering, such as air, gas, and humid air, are relatively close to the ideal gas properties when the pressure is relatively low and the temperature is relatively high, and basically follow the state equation of ideal gas. There are two very important effects for a substance: the intermolecular attraction forces and the volume occupied by the molecules themselves. Therefore, we have the following conclusion. If the effects can be ignored, the gas is an ideal gas. Otherwise, the gas is a real gas. From the microscopic point of view, the ideal gas model adheres to several idealizations. 1. The gas consists of molecules that are in random motion and obey the laws of mechanics. 2. The total number of molecules is not, but the volume of the molecules is a negligible small fraction of the volume occupied by the gas. And 3. No appreciable forces act on the molecules except during collisions. The specifications that constitute the ideal gas model can be summarized as follows. For any gas whose equation of state is given exactly by PV equals RGT, the specific internal energy and the specific enthalpy of a gas depend on temperature only. The specific internal energy and enthalpy of gases generally depend on two independent properties, not just temperature, as presumed by the ideal gas model. Moreover, the ideal gas equation of state does not provide an acceptable approximation at all states. Accordingly, whether or not the ideal gas model is used depends on the error acceptable in a given calculation. Still, gases often do approach ideal gas behavior, and a particularly simplified description is obtained with the ideal gas model. Okay, that's all for this task. Thank you very much, and see you next time.